Year 11 Engineering Studies HSC course. To start off with, it's probably the fast way, so I'm going to go this way. Yeah, that's what we want. Okay, so I'm going to be going through, quickly going through Paul Copeland's Engineering Studies, A Definitive Guide, Volume 1. I'm not going to that page. There we go. Okay, and tools. One day I'll learn that. Keys. Okay, so what do we have? We have some obvious, not some obvious and some not so obvious ideas for the most important engineering innovations. I've included all of these in my post, but I'll just quickly highlight some. So we have the wheel. So starting in the 4th millennium BC, so 6,000 years ago, and it's pretty revolutionary, if you excuse the pun, because wheels turn. Anyway, that's just in the ability to carry things. I had to help my brother move out of his house not so long ago, and boy was I glad that he borrowed a trolley to carry a fridge, because having to carry things without the benefit of wheels it's just night and day in how difficult it is. A quick point is, if you're ever asking people, I'm not saying this in any way reference to my brother moving, just as a guide for young people. If you ever have to move house, make sure that the entirety of your house is packed up before you ask people over, and then make sure that you provide pizza or beer, a beverage at the end when people have finished moving. It's tradition, it's what's expected. And I think this is also looked at in things like Parks and Recreation when Tom moves. Okay. Bronze, iron, and then later we have cast iron, steel, aluminium, and eventually stainless. Just the key metals that we use, and probably the most important materials that we use, with maybe concrete being worthwhile as another point. We have the arch as the key component of structural engineering for a very long time, for thousands of years, and probably 4,000 years. We then have the first major mechanical engineering application. So we have steam engines. So prior to steam, the only power we had was the power of the wind, the power of water, and the power of animals. So it could be a human, or it could be a horse or an ox, but that was it. You really couldn't go faster than the wind could fill a boat's sails, or you couldn't go faster than the speed of a horse until the railway came along. The railway moved so fast that people realized that you could leave a destination and arrive before you had left, and that they needed to introduce time zones because the train moved so quickly. We have the evolution from steam engines to internal combustion. We have then the diesel engine, which is another advancement beyond that. We have the generation of electricity. So I don't think they have DC here, but we have AC. I don't have AC on mine. I only have a DC power. We then have human flight, which is the starting point for what we, I guess, would say modern aeronautical engineering. There was heavier than air flight prior to human flight, so it's worth talking about. There was stuff before the Wright brothers. There is then the helicopter. There's the jet engine, and then we have two important innovations, I guess, if you have to pick one. Transistor is arguably the most important advancement in engineering thinking about how far back you would have to go. I said that Tony Stark, in my last video, I said that Tony Stark's arc reactor would be the most important advancement since Benjamin Franklin, but arguing that it was the most important innovation in electrical engineering since the transistor might not be a bad comparison. Transistor is pretty important. It's hard to say. Nuclear power probably should be on there. I don't think I have that on here, but that probably should be on this list. And the pacemaker is, again, we have to pick something for biomedical. and the pacemaker is a good option. So I have a few more, and we'll have a look at those. So to start off with, I have bronze is the oldest on my list, and then I think followed. Oh, okay. So mine don't go in chronological order. They go based on the chapters that we're going to learn them. So the wheel, I don't cover until, we don't really talk about the wheel until chapter 3, until we do braking systems, where we talk about carts and block brakes, and then eventually disc brakes, and then eventually regenerative brakes, which could be...
Questions in the HSC ask about them in chronological order or based into the chapters?
That is a great question. Okay, so the HSC is based on, it is broken into components. So it will have a section on civil and it will have a section on aeronautical. It won't have anything really, it doesn't directly talk about the Year 11 context, Year 11 content, but, excuse me, what you don't need to know the dates of any of these things. Right, it's important.
You need to know what they are.
You need to know the general times. So if someone said to you, when was the arch developed? You could say, well, the arch was a technique used by the Romans.
Okay.
Or you could say, if you asked about, so I think some clear delineations you can use. You can say prehistory, so things that predate writing. So if we said anything that was more than, say, 500 years before Christ, so more than anything that was more than 2,500 years ago, you could probably say, in prehistory. So things like bronze and the wheel is in prehistory. Then we have things that were used by ancient civilizations, things like the Romans. So that would be even up to steel in some contexts, but probably not. We would tend to say more iron was used by the Romans. Arches were used by the Romans. Then we're going to have things like the Middle Ages. There's not a whole lot that we talk about in the Middle Ages until we really get to, I would say, like the Renaissance and the Enlightenment. So when we talk about things like the stethoscope would be an earlier, like so Victorian era and that sort of stuff. But what we're really looking at is the key distinction we look at is we are interested in the Industrial Revolution. Now, there were actually effectively two industrial revolutions. There was the first industrial revolution that came about due to the steam engine, and then a second industrial revolution that came about after the Bessemer process and the wide use of steel. So there, if you just talk about it in terms of the industrial revolution, that'd be fine. The next big leap forward in innovation was World War I and then World War II. And then after that, I think you could pretty much defer to things as late 20th century. Anything after World War II is late 20th century. And then you could say anything that was in the last 20 years, you just say in the 21st century. So in that, let me see how many groups I have there. I have prehistory. I would say then ancient history. And then I would say we do have a gap. We have middle history, which is before the Industrial Revolution. And we have the Industrial Revolution, which we could say leads us all the way up until World War I, World War II, post-World War II, and then I would say the modern era, which I'd say starts from 20 years ago. I would say anything after 2000 would be modern technologies. So if I said that gives us 1, 2, 3, 4, 5, 6, 7, 8 periods, keeping in mind that I've set World War I and World War II as different periods. Okay, so 8 periods that you can lump things into, and I think with that, that's sufficient. I only have the dates because there's a card game called Timeline where you, and sometimes I play this with students, where I make students guess where things go, and it's nice to have a definitive date to group things into. Okay, so we've got bronze, and then from bronze we have iron. So this is all stuff that we learn in the first chapter. We're just learning about the most commonly used materials. So bronze is still used in some limited applications, but really we're interested in it because it's the first copper alloy. We now mainly use brass, but we use copper for electrical applications. And we have iron. Iron we still use today, but generally we use iron in the form of steel. So we're going to learn about ferrous metals. Ferrous comes from the Latin word for iron, which is ferrium. and we have concrete. So concrete today is probably the most important engineering material, and it was used by the Romans 2,300 years ago. And if you ever have Mr. Zeech as a teacher, or if you ask him about, he's always excited to talk about the Pantheon in Rome. It's a very old Greek structure with a big concrete dome, and it was built by the Romans, and then they just forgot how to make concrete. How does that happen? Well, the idea is that during they didn't write down. Yeah, okay. So during the height of the Roman Empire, Rome took a lot of slaves, and when they took a lot of slaves, it put a lot of the farmers out of work. So farmers would go and move to Rome, where they would get kind of the equivalent of a universal basic income. They got the food dole, and they would live they'd bred in circuses, and they'd live in multi-story buildings, which were made out of concrete. Eventually, Rome fell, and suddenly there was no food to be handed out in Rome. So those people all left Rome, and they went and lived in houses that they built themselves somewhere far off in Europe or in the Eastern Empire, in Greece or whatever, in Asia. The point is that eventually they just got to a point where there would have been a conversation between some grandfather and his grandson where he says, "Oh, we used to make these things out of concrete," and the son's saying, "Yeah, well, no one needs concrete anymore, and it's too hard to get the raw ingredients." So the technology just disappeared because it wasn't useful anymore. And then it wasn't until after the Industrial Revolution that Portland cement was developed and we started using concrete again. Okay, so aluminium smelting is a process that so it came very late, and there's a story that Napoleon III, his royal court, that they had aluminium spoons that the richest guests were allowed to use, and then the poorer guests had to use gold. Now, it's probably apocryphal, it's probably not true, but I think it's a really fun story. The thing is, aluminium requires a heap of electricity to produce. I'm not going to fact check this, but someone can let me know if I'm wrong, that South Australia, their biggest use of electricity is in aluminium smelting. This is why I can't bring myself to throw out aluminium cans, because to make a new aluminium can takes the same amount of energy as it takes to recycle 20 aluminium cans. I couldn't get 20 aluminium cans in the picture, but I thought you got the idea. So the next one is Bakelite. So Bakelite is the first widely used plastic. So arguably you could say things like shellac was a polymer, but Bakelite, which is a phenylformaldehyde, it's a thermosetting polymer, which we'll learn about in Chapter 1, is still something very similar is used in brake pads today. But it was the first widely used plastic, and it really revolutionized what people could have in their homes. Suddenly things like having a radio didn't require a craftsman to to build a radio box by hand. They could instead have a mass-produced plastic container to put their equipment in, and in bright colors too. We have two more modern plastics. We have polyethylene, which is the plastic so nice they named it twice. It's number 2 and number 4. We're looking at number 2, which is the thicker, harder version. That's for milk containers, and the lids of water bottles, that sort of stuff. And number 4 is like shrink wrap. Two-pack shoes was polyurethane. That's a thermoset. It's not in a triangle, not recyclable. Fake leather. Okay, so polyethylene, developed in 1933, is the most commonly used plastic. It's 80 million tons is used every year, at least when I made these pictures. The up and coming, the challenger, like Rocky 5, right, is polypropylene, and polypropylene, or PP, is the second most commonly used and rising. In Chapter 2, we learn about the steam pump. We talk about power and how that's measured in joules, and we talk about steam. and we learn about the Bessemer process, which is where the first mass production of steel. I think it's in chapter 2 we first start talking about heat treatment of steel. So steel, probably arguably the most important engineering material. Certainly, if you consider it to be part of reinforced concrete, then absolutely. Concrete being the only other contender. The Edison, so you learn about, at the end of chapter 2, I think, is where we first learn about electricity and the Edison electric light station. Now, I'll tell you, to be honest, that picture is not actually from the Edison one. I wanted a nice picture, so I cheated a little bit. I think it's still an Edison power plant, it's just not the first one. The first one, I think, is actually in London. In my chapter 2 recording, I said that Edison's first power plant was in Niagara Falls. That was wrong. His first power plant was in London. It ran on coal, but the first AC power plant was developed by Edison, and by Edison's former assistant and then later rival, Tesla, for Westinghouse, was an AC power plant that was set up in Niagara Falls. So I'm making that correction now, so that when you watch that chapter 2 video, you'll say, I remember that Puns was wrong. Okay. Then we've got, for chapter 3, we've got the wheel in Mesopotamia. I don't know if that was the first wheel. I just found a picture of the wheel and that looked good. We learn about cast iron, which was led to the first iron bridges, the first bridges made out of steel, out of a metal rather than stone. And it really was one of the key things in the Industrial Revolution. So we have steam earlier, and then we have, a little bit later, we have the development of cast iron. So Abraham Darby was the first person to really set up a factory where you could mass produce, in this case, pots. And the idea is that prior to this, you needed a blacksmith to hammer out a pot if you wanted a cooking pot, whereas he was able to produce 8 a day rather than 1 every 8 days. Then we have the first car, the Benz Patent Motor Wagon. We learn about this in chapter 3 when we're doing brakes. This is all chapter 3 from the wheel. And we learn about Bertha Benz, the first person to take a long-distance drive, and she developed the first brake linings and a few other suggestions for the first car. That was the more famous first car, is the Ford Model T, which was the first mass-produced car. Right? When we say the Benz Patent Motor Wagon was sold commercially, it wasn't just 1 or 2. They were selling them at scale. But the difference is that Henry Ford developed the production line and was able to produce a massive amount of cars comparatively. Mixed opinions, but Henry Ford was definitely an important engineer in terms of industrial engineering and manufacturing engineering. So 15 million produced. The Beetle was also a very heavily produced car. For a long time, there were more Volkswagen Beetles than any other car. They produced 21 million. That was developed at the request of Hitler by Porsche in Germany in the lead up to World War II. And there are a lot of Beetles around even today, especially in, say, South America. These are the punch buggies. Today, I think the most widely sold car is the Toyota Corolla, but that's because we're living in the modern era and there are way, 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 way more cars than there were, say, 40 or 50 years ago. Okay, which is when it took over. Well, I don't know when it took over, but when they stopped producing Beetles is what I should say. Okay, the Citroen DS19 is interesting because it was innovative because it had a totally revolutionary level of passenger comfort. We'll learn more about innovative cars when we get to chapter 3, where we learn about things like the Range Rover, which was a four-wheel drive, the Mini, these sorts of things. But the Citroen, it was the first. The DS19 was the first one to have. I think it was the first one to have hydraulic brakes. It had improved suspension and it had disc brakes. And it was considered to have much, much better passenger comfort than the preceding cars. The next one, the prosthetic leg, is from chapter 4. So this is the oldest prosthesis that I've dug up, or found a picture of, I should say. And So this is a Roman fake leg that is 2,500 years old. We then have things like, I mean, obviously there were things that led up to that. I don't have the stethoscope here, and that was probably the first diagnostic tool. But the X-rays are a little bit more famous. Not long after X-rays, we had radiation therapy. So anyone who's had chemotherapy is different to radiotherapy. So chemotherapy is where you just have a chemical exposure to radiation. Radiation therapy is where the radiation is shot directly at the point of the cancer. But it's important to say that without nuclear engineers, we wouldn't be able to produce the chemicals that are in chemotherapy because they're radioactive. We learn, when we get to chapter 4, we learn about two different engineering materials. We learn about stainless steel and titanium. So they're the two materials we focus on. So stainless steel, the picture you see there is the Chrysler building in New York. And for titanium, you can see that's a 3D printed skull that's been used for a surgical replacement. We can see, so hip replacements were developed in 1948. Then we have the pacemaker, which is in the book. And so the pacemaker, a lot of people aren't exactly sure what a pacemaker does. A pacemaker ensures that your heart beats in rhythm. So my brother is a GP, and at one point he had a patient come in from Belgium who was in Australia because she was going to participate in a big bike race. So she was going to do the Tour Down Under. And she came in because she had a funny feeling in her chest, and he ordered some tests, and he came back and said, "Oh, you're going to need a pacemaker. You definitely can't participate in this race." And she was pretty furious because this had been her big dream. And I remember him calling me saying, "I probably saved that woman's life," but she was not very happy to receive that news. But the pacemaker, it just helps people to regulate their heart beating and means that they don't die. Okay, so the next one I have is the Sip and Puff typewriter. So the Sip and Puff typewriter I have as an example of an assistive device. So I mentioned earlier that things like a crutch or in the previous part of this video, crutches and canes, they help people to get around. Wheelchairs help people to get around. I don't have wheelchairs in this picture. The wheelchairs are very, very old. Well, the first ones, but then modern wheelchairs are like 1930. But what I find really interesting is the Sip and Puff typewriter was a way for people who were quadriplegics to be able to write things down so that they could remember things when there wasn't someone to tell it to. So what they were able to do is that they were able to sip or puff or into a straw, and when they did that, it would they'd be able to type in effectively using Morse code, replacing the dots and dashes with sips and puffs. And this led to wheelchairs that could be controlled through sip and puffs. And this is sort of a precursor to what we have now, where we have things like we have computer guide. When we talk about fMRI scanners, we can have wheelchairs that are self-driving that can actually read brain waves and brain activity. So many people are familiar with CT scans. CT scans are an advancement on X-rays. The advancement is that an X-ray is a two-dimensional image, whereas a CT scan can give you a 3D model of a body part. So if we want to look for a blood clot, and this is probably where CT scans are the most valuable, is that if you can tell that someone's had a stroke, so if someone has slurred speech, if they can't lift their arm, if their face looks like it's asymmetrical, they're signs that you should take that person to the hospital straight away, because time is really important when it comes to strokes. And what you need to do is you need to take them to a hospital that has a CT scan, and so that they can look for a blood clot. And if they find the blood clot, then they can operate and they can save that person's life, or certainly improve that person's brain activity, because the longer that blood clot's there, the more the brain is going to be starved of oxygen, and the worse that's going to be. That's the same for, I don't want to say definitively, but I don't want to talk outside of my area of competence. So I'd say the wide accessibility, like I remember sort of 10 years ago or more that my brother was working in a rural hospital, and he talked about how one of the things that he wouldn't want to live in the country was that just the distance you are from a CT scan. Whereas these days, even most cruise ships have a CT scan on them. Cochlear implants is a Australian innovation. I think University of Macquarie is. Oh no, it's Melbourne, but they do have a branch in University of Macquarie now. Cochlear was developed by a guy called Graham Clark, and it's the bionic ear. It allows people with hearing difficulties to hear, maybe not perfectly, not as they would like, but it certainly allows them to function in society more productively and often more happily than they would without any hearing at all. I say this. I'm a bit cautious of the specific language I use there because I know that this is a contentious issue, and when we do biomedical at the end of term 3 sort of thing, in term 3 we will talk about some of the ethics and some of the criticisms of cochlear implants. The total artificial heart was originally developed in 1982. If anyone's ever seen the movie RoboCop, they talk about the Jarvik sports heart, and the idea there is that this was made not long after the first artificial hearts. But artificial hearts keep getting better. I saw a post on Reddit just the other day talking about new advancements in artificial hearts. Okay, so fMRIs, an advancement again on CT scans, and what an MRI is magnetic resonance imaging, and the idea is that, as I often mention when we talk about electricity, that in the X-Men, which is now on Disney Plus, the X-Men that I watched as a kid, I did watch it, and I don't know if I can recommend it. It was kind of terrible if you didn't watch it as a kid and love it, when you were 8 in the 90s, but Magneto, he often says that, don't you know, Charles, electricity and magnetism are related? Well, this is true. So when your brain fires, when your brain works, what is happening? Well, whenever you contract a muscle, let's just start there. So if you move your leg, if you flex the muscles in your leg, your brain is sending an electrical signal to the muscle tissue, and when it does that, when the electrical signal is received by the muscles, it contracts. And your brain is doing that by sending electrical signals. And what we can do is we can detect the electrical activity happening in your brain with big magnets. And this is why if you get an MRI, you have to make sure that you take out everything that's magnetic. In the office, when Dwight has a concussion and they have to tell Michael to put the magnetic stuff, Michael wants to take his crutches in there, and don't take crutches into an MRI because you could destroy a $20 million machine. I could even be more than $20 million. I haven't bought an MRI recently. So MRIs, what they do is they allow you to see where the brain activity is. And this has really been an amazing advancement in things like psychology, because up until now, if we were doing psychology, all we could really do is ask people surveys, or we could observe behavior of individuals. Whereas now we can actually see, we can learn about parts of the brain. We can see that when people read, when they're in an MRI, one part of their brain shows more electrical activity than it normally would. And so in this case here, it's not to say that only a small part of the brain is using electrical activity. The whole brain is having some electrical activity. But what we can see here is the areas where there's more than usual electrical activity. And so we can say, when the person reads, this part of their brain is demonstrating more electrical activity. There's still the electrical activity that's required, say, to keep your lungs working. That's always happening all the time. Whereas if, on the other hand, if, say, someone is thinking about, lying, we could get to the point where we might be able to use fMRI scanners to detect lies. Or what we can do at the moment is we can do things like we can say, think about books or think about apples. And because we think about food in a different place to where we think about language and books, that we can detect that difference in activity, and we can use that to guide things like a self-driving wheelchair or to control a drone and without touching things. Eventually, people like Elon Musk and his Neuralink project might get to the point where people could access the internet without having to look at a screen, where we can just directly stimulate those nerve endings directly. So fMRI, you can see I've spent a lot of time on this point because I think it's pretty interesting, and that's, yeah. Okay, I'm going to move on. Göbekli Tepe, I don't know if I said that right, is a Turkish temple that is 12,000 years old. It is the oldest, it was way, way, way older than the pyramids, that we'll see in a second. And it happens to correspond roughly to around about the time that wheat was domesticated. There used to be wild wheat, which was hard to collect. And then all of a sudden there was a evolutionary change in wheat, that suddenly you could collect wheat way, way faster. It didn't all fall off. It all clumped together. And you could collect wheat off the stalk. And suddenly there was so much extra food that presumably these people in Turkey, they could spend their free time that they would have spent collecting food, thanking the gods or something, and building this 6 meter tall temple. I mean, it's twice the height of a person. Because 12,000 years is a long time, it got buried in sand until eventually it was just accidentally dug up. But it really changed our thinking of the nature of Western civilization. It's one of the oldest buildings we know of. And there's some people who suggest that rather than using things like BC or before Common Era as a counting system, what we should do is we should just add 10,000 onto everything, because so Kierkegaard makes this argument in their In a Nutshell videos. So the human era could be measured from about this time. This is the first civilization, where civilization meaning people gathering in fixed communities where there's enough food that people can specialize in different skill sets. So someone can focus on just being a warrior, or just being a healer, or just being a artist, for instance. Okay, so we're going to move on to the pyramids, which are about 4,500 years old. So way, way younger than Göbekli Tepe. And it's interesting to know that, say, Cleopatra, she's closer to us than she is to the Great Pyramid of Giza. It is my ambition to go to Egypt one day and to eat at the KFC that you can. There's a KFC where you can see the Great Pyramid. It was the tallest. It's 147 meters tall, the Great Pyramid, and it was the tallest building for thousands of years. Apparently, during the Caliphate, they tried to destroy the pyramid as being sort of blasphemous, and they found that it was actually just as hard to destroy as it was to build. So, I don't know, it's pretty interesting. So we've talked before... sorry? Yeah, that's right. We talked earlier about arches. So when I may have talked about the introduction to bridges, but we definitely, when we start the Year 12 course, we'll do the introduction to bridges, where we talk. So Year 8s may have seen, some of you when you're in Year 8, you may have remembered I did a talk about different kinds of bridges. And the stone arch is sort of the first bridge that moves on from just relying on a dead tree crossing the river. So the advantage of stone is it doesn't burn, it doesn't erode. Well, it doesn't erode nearly as much as wood does. It doesn't decompose, and it can span longer distances when you have these arches. And they were critical to the success of the Roman Empire, both for transport and also for water supply. They had built viaducts as well. The Roman Colosseum is a pretty massive stadium. It was built in 80 years AD, 80 years into the Common Era, and it held up to 80,000 spectators, which is like as much as the MCG. So it's pretty amazing. The Lincoln Cathedral was the first building taller than the pyramids, if you include these spires. But those spires fell down. So for a long time, people were like, were there really spires? But now historians believe that there probably were spires. And these, with the spires, there wasn't anything taller than the Lincoln Cathedral until we get to the Eiffel Tower. The longest bridge for a long time, and we can see a big jump between 1,000 years, is what some people call the Dark Ages. Not everyone likes the term Dark Ages, especially Christian historians don't like the term, but a long time with not a lot of innovation, which is why you can see that we sort of wait until we get to the Industrial Revolution. But we have the we have a suspension bridge. So in this particular case, this suspension bridge isn't a suspension bridge as we would know it. This is more like a rope bridge that's just made out of iron. But we have the longest suspension bridge, or the longest bridge for a long time was, and I go into way more bridge history. If you really want to, like, if you can't sleep and you want something really boring to put you to sleep, I have about an hour of YouTube videos where I talk about bridges. And I mean, even I'm bored by it when I watch it myself. Anyway, so in Tibet, there are these bridges, and these suspension bridges, and they were pretty long, and they were the longest bridges for a long time, a long time. But after the Industrial Revolution, when we started to get to Abraham Darby, I think may have had a role in the building of Iron Bridge. I don't want to say that definitively, but the Iron Bridge was the first bridge not made out of timber or stone. And initially, people thought, oh, that's never going to work, until the river flooded and about 6 other bridges on the river were all washed away, and the Iron Bridge stood, and it led to a revolution in bridge building. The Suez Canal, now that is old. The Suez Canal is what joins, this one really could benefit from a map, is what joins the Mediterranean to the Red Sea. So basically, if you wanted to get to Europe to Asia, you either have to go around Africa, or you can go through this thin point in Egypt. And this is the sea that I think, pretty sure it's the Red Sea that Moses parts. Anyway, this canal allowed people to sail much faster to India and to Asia by a canal, and it was built by, I think, the French, Ferdinand de Lesseps, and it's drastically shortened the distance needed to be travelled, and also the safety, because along Namibia there's something called the Skeleton Coast. It's interesting to look up. And the idea is that the wind blows the wrong way, so that ships would crash there. And because the wind blows the wrong way, they could never get out. And it's just nothing but desert. There's no water, there's no plants, and you just die. Okay, around about the same time was the Tube, the first, the London Underground, the first major railway. Well, in this case, it was an underground railway, but okay, the Eiffel Tower, the tallest building for more than 40 years. So it took a long time for something to beat the Lincoln Cathedral, and it came along and it smashed it. It was twice as tall. So I don't talk about the Crystal Palace in this. I don't have a poster for the Crystal Palace. The Crystal Palace was built for the London Expo, I think 8 years prior or something like that. And I really should know, but I'm not going to look it up. And this was during the time of Queen Victoria. They built using the new technology of cast iron, they were able to use prefabricated cast iron structure and glass panels to effectively produce a palace in, I think, Hyde Park, just not overnight, but in a very short time frame, in only a year or two. Again, I'm not entirely sure I'm estimating here. The point is, it was amazing. It was amazing how quickly they were able to build this huge building, and it was an international marvel. And so the French, not to be outdone, they said, well, what can we do with this wonder of cast iron? And what they were able to do is they were able to make the world's tallest building, and not just the world's tallest, but twice as tall as the pyramids. It was again, initially intended, like Crystal Palace was taken down and relocated. And for a long time, Eiffel Tower was originally planned to be taken down because it didn't really serve any purpose until the radio came along, and suddenly they just had an obvious place to use as a radio transmitter. So many other countries now have similar towers, like Tokyo, for instance, has a tower. Sydney has a tower, which their purpose is, and we're going to talk about the Canada Tower in a second, the CN Tower, as radio transmitters. The fourth bridge is a cantilever bridge, and it's interesting just because it's a very, very different bridge design, and it was I think for it to be on this list, it was also the longest bridge in the world at the time. So yeah, 520 meters, that's pretty long. Longer than Sydney Harbour Bridge. Okay, So we then have the Empire State Building. These two buildings were both built during the Great Depression, or the start of the Great Depression. They started during the Great Depression. And so the story of the Empire State Building is that the teams who built it, would be four people building the four people in a team. So it was both steel structures, and to hold the steel together, they'd use red hot rivets, which in year 8 you probably would have learned about rivets and how we heat them up and then bash them over to hold things in place. And we will talk about that more in detail. And so the idea is that was one person who sat next to the fire, who heated up the rivet. The next person would pick up the rivet and throw it. Another person would catch the rivet, and then the third person would hammer the rivet. And they say that for the Empire State Building, if one of those 4 people was sick, no one went up. And that was because you're dealing with building 300 meters in the air, where there wasn't really the safety technology we have today to stop red-hot rivets falling 300 meters to the people in the street below. Apparently, because people knew that this was likely to be the last job that they were going to get because of the Great Depression, people worked pretty industriously. Similarly for the Sydney Harbour Bridge, the Sydney Harbour Bridge was a real icon of resilience during the Great Depression. It gave people hope. It was a symbol of resilience during the Great Depression. It was the longest single span of a bridge because the fourth bridge, I don't think that's its single span is 520, but I feel as though it was the longest single span for a bridge, except that shortly after, like a month or two later, a bridge somewhere in Philadelphia, they built a bridge that was 60 centimeters, 600 millimeters longer. The bastards. Anyway, Golden Gate Bridge was built just the following year, and then there was a new competition for longer span, and that was 1.2 kilometers, and it was the longest span for over 30 years. It's a symbol of San Francisco. I don't think there'd be many people who go to San Francisco and don't cross the bridge. My kids, we went over the bridge. It was freezing. It's often covered in fog, so you have to be lucky with it. Carl the Fog, that's what they call him on Twitter. Anyway, most photographed bridge in the world, supposedly. The Hoover Dam was a engineering marvel. It is, I think, if you've ever been to Las Vegas, all of the water and electricity comes from the Hoover Dam. It's now pretty much fully automated so that no one person can stop the dam. We're going to learn about other bigger dams, but engineering marvel. It could easily be in the top 10 engineering marvels of the 20th century. The Snowy Mountain Scheme is Australia's equivalent, and it is Australia's largest engineering project. Certainly its largest civil engineering project. These days, arguably, you could say the NBN is the largest project since the Snowy Mountain Scheme. What do we got next? The CN Tower. That's again not only is it an agricultural project, but it's mostly a hydroelectric project. The CN Tower is one of these tall towers we talked about before. It's there as a radio tower. It's probably most famous for having a oversized Drache the musician, who's from Canada, sitting on this thing. And I think these windows are 3 meters tall, and so for Drache to be sitting on them, Drache would have to be 6 meters tall. But obviously he's not really sitting there; it's photoshopped. But it's funny just how ridiculously big he is on the video, on the picture. The Sydney Opera House is a famous Sydney landmark. I'd say it's probably a famous Australian landmark. It was. It's built out of concrete and it's got tiles on the outside. When you walk up to the Opera House, there's a lot of exposed concrete because it has such a high quality finish. People said, "Hey, we should be proud of this concrete. We don't need to hide it." A lot of people think you probably should hide it, but the point is it's an iconic building, and if you live in Sydney, you should make the most of it. Whenever you have people visit, make sure you show that. They'll probably ask. So the largest stadium in the world as of 2017, which is the one I made these pictures, is in North Korea. It's a big stadium, and every year they have a big party and they fill it with people. The Akashi Kaikyo Bridge, so it's like the Akashi Strait. I think it joins Kobe Island with the mainland of Honshu. It is now the longest single span in the world. It's nearly 2 kilometers long, and it is a long bridge. There are long bridges. There's longer bridges, but they have more spans. So there are longer bridges in China, and I think the one that joins the Netherlands, sorry, not the Netherlands, Norway and Denmark is pretty long. But when I did this, it was the longest bridge in the world. The Three Gorges Dam is now the biggest dam. It flooded a huge part of China. A lot of people upset about individual towns and ecosystems being lost to it, but China doesn't do small things, and Three Gorges Dam is a big hydroelectric project. The Burj Khalifa was the tallest building at the time I made this. I think it still is, but I'm not entirely sure. It is very, very tall. It's taller than CN Tower, which was the tallest structure for a long time at 500 meters. Yeah, so it took over. The New Century Global Center, I'm really disappointed that I didn't go. I went to Chengdu just after. So Chengdu is in Sichuan, which is in sort of southwest China. It's where the pandas are. And I am disappointed that I didn't go there when I could have said I've been to the largest building in the world. Largest building by sort of square feet or square meters. The Pentagon was the largest building in the world for a long time, and if you just look at Google Maps and see just how big the Pentagon is, it's pretty impressive. I don't have a picture of the Pentagon. I mean, I guess because it's no longer the biggest building. I went and saw the Pentagon because I'd seen, I knew that it was the largest building in the world, and I was excited. It was the largest building in the world when I went to the Pentagon in 2003. And I got off at the station, and some armed guards. This was 2 years after the terrorist attacks on the World Trade Center. Some armed guards asked me why I was getting out at this station, and I said to see the Pentagon, the world's largest building. And he said, well, there it is, get back on the train. I don't even know if he was that friendly. And when I looked at it, it was just one big grey wall. Because if you can't see, if you're looking at it from ground level, it just looks like one big grey wall. So that was an interesting train ride for no good reason. But, I guess I've got that story. So Boeing, they built the largest single building to house and test their planes. And there is the tallest single-story building in the world was built in... We will watch this when we learn about gravity. The longest single-story building, it actually gets its own clouds, and they use that so that they can test the space shuttles. I think that's in Houston, but I could be wrong. Maybe in Florida. Anyway, Dubai Airport, I guess that was also a very big building. I don't really remember why I wrote that now. It's a bit embarrassing. Okay, so that's our structures. Now we're going on to transport. So the Grand Canal, this is one of those ones where it really, I talked about Suez Canal. Suez Canal really should be in transport as well. So, because these really, you can think of canals as being sort of like water-based railroads, that they allow transport along the rivers. The Chinese, the canal that joins the Yangtze River to the Yellow River, there's a giant canal. It's still there. You can still go down it. Stevenson's Rocket. There's a board game called Stevenson's Rocket. I'm sure I'm going to mention that board game at least twice more before you finish with me. And it's okay. It's a Knizia, which my friend loves Knizia games. It's a solid game. It's a 7.5. But the train was the first. Was an influential steam engine. It wasn't the first. It wasn't the best, but there was an episode where there's a engine called Stephen in Thomas the Tank Engine, and when I saw that, I was really excited, and I took a screen capture and I put it on my Facebook. Yeah, Stephenson's rocket, influential. We could say it's effectively the first train in 1829. There's also a series of board games called 18XX. The first one was called 1829, and they're all based on different different railways all over the world. So, like 1889 is in Japan. 1830 is probably the most famous. It's in America. It features Scranton, the electric city. I like 1849 and 18. After a while, they start replacing the numbers with letters like 18CZ and 1862 is good. Anyway, there's lots of them. Okay, so Velocipede. The Velocipede is. It's really hard to say definitively what the first bicycle is. We will watch a video where we watch people racing the first bicycles, the ones in 1870, versus bicycles made only just a few years later, maybe 15 years later, which had pneumatic tires and hollow tubes, and we can see what a difference it makes, the evolution of bicycles in the first few years. I think Copeland says his first bike is a lot earlier. I think he has it in 1830s. Let's see, does he have bicycles here yet? He might not have it until we get to chapter 2. I know no one likes this, that it makes them sick. Might actually be in chapter 2 of the following. Yeah, it is. It's not until next year. Anyway, I'm not going to get next year's book. Okay. This is the date I've got. Carl Drees Laufsmaschine. So Laufsmaschine is the running machine. So I don't even think that one you didn't even have pedals. But you got to pick something to be first. Then we have the petrol engine. So 1876, the first internal combustion engine. Prior to this, everything else had to run on an external engine, things like steam. We still use steam engines today, though, to generate electricity. Panama Canal. So we learn about these other canals. Well, the biggest canal in the world these days is, well, probably the most significant commercially is the Panama Canal. So the same idea that rather than having to, if you wanted to go from New York to LA by boat, you would have to go all the way down past what they call that, Argentina, the Tierra del Fuego, where it's so close that you can actually see Antarctica from the land. It's terrible weather. It's really, really hard to navigate. You can hit ice. It's very dangerous. So instead, you can go through the Panama Canal. The Panama Canal has... so the same guy, Ferdinand de Lesseps, he tried to build the Panama... There's a whole video on this. What is it called? The Seven Wonders of the Industrial World. They have a video on the building of the Panama Canal. It was difficult to build because it was going through mountainous terrain with a lot of diseases for Europeans, through jungle and things. And it runs on a series of locks, which is very interesting. And because it runs on locks, there's always water that's lost. And so there are times where the Panama Canal can't really operate because they need to wait for more rain to fall. And now there's opportunities for other countries like Nicaragua to try and build. And I think the Chinese are in talks with Nicaragua to develop their own series of their own alternative canal because it is expensive to get things through the Panama Canal. Okay, the Seikan tunnel is, so I wanted to have the English tunnel because I thought that the channel, as it's sometimes known, CHU, anyway, because it's the channel, the English channel. Anyway, but the English channel is neither the first nor the longest, so I thought in that case I'll just go with the longest, which at the moment is the tunnel that connects Honshu to Hokkaido, which is 23 kilometers directly, but I think in actual fact it goes in a weird way. But anyway, what I got here is it's 23 kilometers. Then we're on to chapter 3 of the Year 12 book, which is aviation. Aviation, we're going to learn about lighter than air flight. So this is the hot air balloons. I believe the word in French for hot air balloon is montgolfier. I'm not sure if I'm pronouncing that right, but you take a stab at it. But the hot air balloons, so they were first. We also learn in this chapter about carbon fibre. We do talk about it in other chapters, but this is where we really talk about the production processes. We talk about autoclaves and hand layup. And that's an old material. It's 1860, the first carbon fibres, which I was surprised at. Then we have the Wright flag. This is, if I was going to learn one date, this would probably be the date I'd learn, 1903. And it's really interesting that the time between 1903 and 1969, when they landed a man on the moon, that it really wasn't a very long time, 66 years, from people flying in a little dinky plane that could only initially go a few hundred meters to being able to get someone in a dinky piece of metal all the way to another planet, well, another world in the moon. So I think that's pretty amazing, and yeah, I'll leave it at that. Transatlantic flights. So only 15 years after the first planes, people were able to fly across the Atlantic Ocean. Sydney Airport is the oldest civilian airport. I think in Germany, Hamburg Airport or something like that might be the oldest airport, but that was a military airport that was built for World War I. Sydney Airport, I guess because we're a long way from the rest of the world, was the oldest civilian airport. If you ever are going through the airport, they have, I think at the domestic terminal, they have a interesting museum, and I'm surprised they don't make more of a thing about the fact that they're the oldest civilian airport. Gloster Meteor is the first jet. It did see some service in, I used to actually have a different picture. I used to have the German Hinker 176 or something like that, HE 176. The fact is that it wasn't ever really used in production, whereas the Gloster Meteor did see some use during World War II, and then I believe it then was later used in the Korean War. These are out of order because I changed that. The Hinker that I mentioned was in, I think, very early in the war, but it wasn't viable. The Drache, which is German for dragon, is the FA-223, was the first field helicopter, and then Chuck Yeager, which is a pretty cool name, he was the first pilot to go faster than the speed of sound. For a long time, people thought you just couldn't go faster than the speed of sound. The idea is that if you had a really, really, really long ruler and you wanted to push the light switch just using that ruler, the fastest speed that you can push that ruler is the speed of sound for that object. The speed of sound is different for different materials, but there is problems, there is difficulties with flying faster than the speed of sound. We will talk about that. We may have looked at that in your class when we were in Year 9. You might have watched a video on the Concorde and the difficulties of flying faster than the speed of sound. But they were able to get there, and it is now a big factor in modern Air Force, or what do we call that? Military aircraft. Flying fast is really important. The Vostok 1 was the first spaceship. I guess that's one, first space flight, and that's again a cool name. Yuri Gagarin was the first person in space. The Boeing 747 was the plane that carried the most passengers for 30 years. I'm recording this in 2021, and last year Australia saw the last 747s. They got phased out because these days we don't like large capacity planes typically. We generally would rather have smaller capacity planes, and we're talking about a plane that is now nearly 50 years old, and the technology is 50 years old. That when we have really big passenger planes, we use the A380s, but the A380s have been phased out as well. And these days, the Dreamliners, the 787s, are the go-to plane for Boeing. So, with the International Space Station is the most expensive thing ever built. It's expensive. The movie Gravity, you get to see it get all destroyed, and I'm like, wow, that would be very expensive. It's not as expensive as Superman, that Man of Steel movie. They say is like the most expensive disaster in any movie, but the movie Gravity, a lot of expensive stuff gets destroyed, which is unlikely to happen. It's not scientifically accurate because they all are in different orbits. but still, I guess a concern that small amount of debris could tear through a spaceship. Keep that in mind if you ever get an offer to be an astronaut. So the A380, it was developed in 2005. It was the largest passenger vehicle as of 2017. I would say it was likely to be the largest passenger vehicle for a very, very long time because they're not making them anymore, just because it's no longer really commercially viable. They were designed for a different time in terms of, or a different economic environment when people were more willing to fly from one destination and what we call wheel and spoke flight, which is much less common these days. So being phased out. And then finally, we're on our last chapter. This is what we do at the fourth topic in year 12, is telecommunications. And we start with Morse code. So there were ways of communicating long distances before Morse code. In the Trojan Wars, they say that the news was sent home to Greece via beacons that were set up on different islands so that people could see messages. If any of you have seen the cartoon version of Mulan, right at the start, they light a beacon and the other lights go along the Great Wall, and the next person sees the light and they light their light and it sends a message at quick speed. The problem is you can only really send one message. You can only send, we won the war, or the Huns are crossing over the wall, that sort of thing. Or the Mongols, whatever. Whereas then there were towers developed, semaphore towers set up by Napoleon, and they were interesting and innovative, but they were quickly replaced with Morse code. Anyone who's ever read Going Postal, which is a Terry Pratchett book, it's very good. I'd highly recommend it. They talk about, you might remember the story with Mr. Pump? Yeah. Mr. Pump the Golem. Anyway, that's a story where they talk about machines that are very similar to these clacks. The clacks machines are very similar to these semaphore towers. The problem is that not long later, they were phased out because of the telegraph. Morse came along and developed a way of communicating at even faster speeds. We then have the next big advantage, innovation, is the transatlantic telegraph. This is a section of cable that was used to, I think it was the Great Eastern, which is a big boat. It has another episode of the Seven Wonders of the Industrial World, was the only ship that was big enough to carry the transatlantic cables. We watch a video in year 12 where we learn about this, and a bit of a spoiler, it broke, and then they had to replace it. I think Queen Victoria was the one who sent, yeah, it's about right. Queen Victoria sent a message over the telegram. She was the first person to the US president. I can't remember who it would have been at the time. But it broke, and so they just had to lay it again because it was so valuable. The telephone was invented by Alexander Graham Bell in 1876. I think that he got his patent in on the same day as someone else, but Bell is the one who, he was the one who got his patent registered, and he became very successful as a result of that, and we now just take telephones for granted. The radio telegraph was developed by a guy called Marconi. In Sydney, the Italian club is called the Marconi Club, and Marconi is sort of a big hero of modern Italian culture. He was working in London, I think, for the British Post Office, and they say that everyone who survived, including Rose, who wouldn't share the door. You didn't watch the end, did you? Anyway, at the end, Rose, she doesn't share the door, the floating door with Jack, and a bit of a spoiler. Well, anyway, I don't know. I think it's old enough that I don't need to worry about that. Anyone who survived in the in the Titanic, they survived because they were able to send out a radio signal to I think Lusitania was the one that picked them up, the sister ship. I could be wrong on that one. Don't quote me. I'm almost certainly wrong. I think the Lusitania was the one that got sunk in World War I. My brother would know, big Titanic fan, and he'd be like, oh, duh, of course it's this. Anyway, moving on. The transistor, I said earlier, is arguably, certainly it's the biggest step forward in the history of electronics, and the arc reactor could be an interesting competitor to this. The transistors are tiny switches. This one is not so tiny. This one is it's still very small. It's hard to tell at this scale, but I mean that's wire is not very thick, so it's maybe 10 mil or something like that. But yeah, they're tiny. These days, we can the silicon chip in a computer, which is about 50 millimeters by 50 millimeters, it holds 1 billion transistors on it. So it's pretty amazing how small we've been able to get transistors in 70 years. We're getting to the point actually where the transistors are so small that we might be getting too small, and that if we go any smaller, that electrons will be able to pass through without being stopped at the gate. In which case we'll have to use something like quantum computing, which could be another big innovation in electronics. That's probably the next big innovation in electronics. In terms of satellites, I only have one satellite on here, and that's Sputnik. Sputnik was launched in 1957, and I've spoken to people who were alive and who remember it, and they said that they looked up at the sky, and suddenly even the sky felt like it was had been captured by the enemy. So it's pretty interesting. It's only very small. This picture doesn't really accurately depict what it looks like. I have seen a replica in the Smithsonian. It's bigger than a tennis ball, but smaller than a basketball would be my approximation of its size. It's silver. Yeah, Sputnik. Email is way older than you would think about. I think 1962, and they weren't just the military wasn't just sending 1 or 2. They were sending 30 million emails per month. I mean, obviously these days the number of emails we send is astronomical, but yeah, email. Yeah, email is great. Email is and the technologies it allowed for things like RSS, probably in the age of people not trusting social media, email is probably the one great technology that we have, and it's great because it's open source. Laser printing in 1969 by Xerox is a good example of a technology that's so different that it's kind of amazing that someone even thought about it. The idea that if you shine a laser over a piece of paper, ink will want to stick to it is pretty amazing. I've heard people say that it's probably the most the innovation or the invention that is the most original, that didn't build off preceding technologies. Xerox is also famous for developing the graphical user interface that we now that was stolen by Bill Gates and by Steve Jobs for Microsoft and Apple. There's a great movie called Pirates of Silicon Valley that I've made my kids watch. There's a few bits that I had to skip because some of it is maybe not age appropriate for school, but it's a great movie talking about the early days of these two massive tech companies. Okay, optical fiber communication. This is we now the backbone of our internet, that we can send a lot of information over very, very fine pieces of glass and very, very pure pieces of glass. This was a real innovation. I talked earlier about a video Lightspeed that we will watch in Year 12, where we talk about the process of actually drawing glass within glass so that we don't get any impurities, so that we don't lose any light. And it was actually effectively predicted by Bell a little bit. Okay, so HTML is what I think is a good starting point for what we can think of as the modern internet of the World Wide Web. What is this the code for? This looks like it's the code for UTS Engineering, which is where I went to uni. And so, yeah, this is the text that builds all of our websites. And then finally, the last page is Wi-Fi. Wi-Fi is an Australian innovation. It was developed by CSIRO, and it was actually used to connect the square kilometre array. It's a series of radio telescopes that Australia won as for radio telescopy. So I just watched the movie Contact today with my daughter. and that's about big satellites that look up in the sky. And in order to communicate between those satellites, they developed a technology called Wi-Fi, and they then licensed it. And I remember hearing about Wi-Fi in about 2001, 2002, and thinking, oh yeah, that's going to be a big deal. And someone was saying, like, you don't understand, like, you won't have to plug your computer into your router anymore. And I was thinking, oh, that'd be really nice. And I guess my kids, they've never known a time before Wi-Fi, that it's just been on everything. And now with 3G, it's pretty amazing. A lot of people I know who worked at the CSIRO, well, a couple of people I know who worked at the CSIRO, they basically talk about how their paychecks came from the royalties they got from the Wi-Fi and license. Lenovo didn't want to pay it, and then they got sued, and then they had to pay it. That is my last innovation, and that is going to do it for today's video, I think. I will just quickly look at what are we going to look ahead. The role of engineering. Yeah, that'll do.